Hi there, my name is Eric, and we're going to do a video today on an algebra topic. Properties of powers, working with powers, everything you want to know about powers. And including negative exponents and rational or fractional exponents. And my students have some trouble with this, so I'm going to do my best to make it clear. And I hope you find this helpful. So let's get started. First of all, what is a power? Power is a structure like this. The whole thing's considered a power. It's got parts called a base and an exponent. This is the base, this is the exponent. And it is shorthand repeated multiplication, is all it is. So this quite literally means take 2, the base, and multiply with it. Again and again, again and again. No, not that many. Just until you have 3 factors. So the exponent counts the number of factors. The base tells you what the factor actually is, and then it's your job just to come up with the answer. And of course, the answer to this is 8. Now, let's take a look at some powers of 2, just because 2 is easy. 2 to the first, what does that mean? Well, that just means 2. It means you have one factor of 2. 2 squared. 2 to the power of 2 means 2 times 2, which is 4. We just did 2 to the third. That's 2 times 2 times 2, that's 8. 2 to the fourth is 16, because 2 times 2 times 2 times 2 is 16. How do you get the next power from the previous power? That is, if you wanted to go from a 4th power to a 5th power, and you somehow wanted to use this instead of having to multiply all these 2's together, maybe you could use a little trick like this. Okay, the 5th power of 2 compares to this number in the following way. That's how we got 16. And if you're going to go up 1 power above the 4th power, up to the 5th power, all you're really doing is throwing another 2 in there. A 2. That's what takes you up to the next power. Well, this was 16, and if you multiply that by 2, you are in fact going 1 power higher. That's the way it works with a base of 2. So if you wanted to go even higher than that, well, I can't reach that high. 2 to the 6th would be 32 times 2 is 64. Now, I'm more interested in going the other direction. How do you compute a lower power given the answer to a current power? For example, 2 to the third is 8, right? If you wanted to take this 8 and figure out how to drop down from power 3 to power 2, you just take this 8 and divide by 2. And that's really the secret to understanding what powers with negative exponents are. Okay? You want to go from 2 to the 4th down to 2 to the 3rd, just take 16 and divide it by 2. You get 8. You want to go from 2 to the 2nd down to 2 to the 1st, just take 4 and divide it by 2 and you get 2. Now here's where the strange stuff starts to happen. What if you want to go even lower than 2 to the 1st power? I mean like 2 to the 0 power. Well, the pattern holds. You just take the last answer and divide it by 2. What's 2 divided by 2? 1. And the first time you come across this in mathematics, it's kind of alarming. It's counterintuitive. 0 power? The 0th power of 2 is 1? It is, and that's not unique to 2. 5 to the 0 power is 1. 12 to the 0 power is 1. There's only one exception to that, in fact, and we're not going to talk about it here today. But if you wanted to go lower than a 0 power, you could go to the negative 1 power. Easy. Just take the last answer here and divide that by 2. 1 divided by 2 is 0.5. Written as a fraction, it's 1/2. You have a whole pizza. You divide it into 2. Each part of that pizza is called a half pizza. Let's go lower. Let's go lower than a negative 1 power and go to negative 2. Okay, now here's what you're going to have to know something about fractions. You have to know how to take a half and divide it by 2. So a picture illustrates this nicely. Here's a pizza. Okay? Here's half a pizza. And dividing that half pizza in 2 quite literally means cutting it like that. Now, do we know what those pieces are called? Yeah, they're called 1/4. Now look what's going on here. 2 to the positive 2 power is 4. 2 to the negative 2 power is 1/4. Well, the pattern actually continues. 2 to the negative 3rd power can be found by going 2 to the positive 3rd power and just putting an 8 under a 1. So from this, we get a property of exponents. 2 of them, actually. One of them says that a to the negative k power is 1 over a to the k power. It basically just says put those factors of a on the bottom. After all, 1/8 is the same as 1 over 2 times 2 times 2. All those 2's that you see there, you still have 3 of them, they're just underneath. Now the opposite is true. If you have a negative exponent on a power that's already in the denominator of the fraction, those essentially go back to the top. And I can give an example of that today, but our goal is not to focus just on negative exponents. We've got other things to look at too. So we're going to need those 2 properties today. Now here's something else that's kind of surprising. There's such a thing as a fractional exponent. Take, for example, 25 to the 1/2 power. Play around with this for a minute on a calculator, and you'll find out that the answer to this is 5. Take the square root of 25. You'll also get 5. Pick another perfect square to make this easy, like, I don't know, 49. On a calculator, 49 to the 1/2 power is 7, and the square root of 49 is also 7. You get what's going on here? There's such a thing as a 1/2 power, and it does exactly the same thing as a square root. And that's not unique to the 1/2 power. There are other fractional powers you can use to do sort of the same thing. For example, you may know about cube roots. Okay, if you don't, the cube root of 8 basically asks the question, what number can I multiply by itself, by itself, by itself to get 8? Do we know the answer to that? Yeah, we saw that at the beginning of the lecture. These all have to be 2's. So the cube root of 8 is 2. What's the cube root of 125? Well, it's the answer to this question. The 3 tells you how many factors you're supposed to have. The 125 tells you what those 3 factors are supposed to multiply to make. Can you think of a number that multiplies by itself to make 125? Yeah, 5. 5 times 5 times 5 is 125, so the cube root of 125 is 5. Now, here's what I was talking about a minute ago. Take your calculator and take 8 and raise it to the 1/3 power. Guess what you get? Yep. Take 125 and raise it to the 1/3 power. Guess what you get? Yep. So, what's the property that we're trying to get after here? Well, the most basic thing I'm trying to communicate is sum base A raised to the 1 over n power is the same thing as the nth root of A, provided that that root exists in the first place. We can get into trouble with this if n is an even number and A is an odd, if n is even and A is negative, this can cause a lot of trouble. But if we stick to positive numbers A, we won't have any trouble and this property holds. Okay, so just in case that stuff is not familiar to you, I wanted to get that out there. Now, I'm going to do another video in just a minute where we run through an entire review process, lots of properties, some of which deal with these, and I wanted to make sure you knew about these properties. So, so don't go watch the second video until you've watched this first, unless you're comfortable with it already. Be back in a minute.